I am going to present this one on GIS applications for medicinal plants conservation. Since I didn't know who the audience is, I have to start with why do we need this kind of thing, GIS mapping and all. So first of all, we have to appreciate that the wild resources are declining. Many of the species are moving towards extinction because of overexploitation, because of habitat loss and degradation, combined these factors. For taking any informed action on the ground for conservation of medicinal plants, we require a very comprehensive and reliable database on what are the plants, where are they, how are they distributed, which of these are wild and where, and which of these are of conservation concern. Since FRLHT has been into this medicinal plant field for more than 20 years, and actually we started our work as a project for conservation of medicinal plants in southern India. So the challenge was to figure out which plants we are talking about. So when we started long back in 1993, we had to take up medicinal plant conservation action in 3 states, Karnataka, Kerala and Tamil Nadu. And when we started looking for which are the medicinal plants, there was no comprehensive list available anywhere which could tell us which are the medicinal plants. Which of these are wild, which of these are endemic, means found on restricted areas, which of these are now moving towards extinction, reducing very fast, and for which the conservation action is needed. None of the answers were available. So we started building our own database. So it's more than 20 years that we have been building a comprehensive database on Indian medicinal plants. And that forms the base for mapping species. Our mapping is for natural distribution, wild presence, not for planted ones. So over so many years we have been building a database on Indian medicinal plants. Must clarify what is an Indian medicinal plant. The one which is used or known to be used in Indian traditions for medicinal purposes. Indian traditions are both codified and folk. Codified is Ayurveda, Siddha, Unani, Tibetan, which is now known as Sovarikpa. In these Indian systems, the things are written out. You have documented, written out scriptures which tell you the various theoretical foundations about how to use, what to use. But apart from this, there is a oral tradition, which is folk. A lot of tribal communities are using their own healthcare medicines, plants there, and that largely is undocumented. Still, in spite of thousands of ethnobotanical studies done by botanists of our country, still lot gap is there. But whatever is available in the form of those ethnobotanical documentation, that also we have taken into account for building what we call a database on Indian medicinal plants. So one of the starting questions is how many wild Indian medicinal plants need such mapping. We said we should map the natural distribution for informed conservation action. So how many are such species? So for that we need to see how many are wild medicinal plants. As I said, we build a database. In the database currently we have 6560 medicinal plant species recorded for use across these systems, Ayurveda, Siddha, Unani, Sovarikpa and folk. Even part of homeopathy, wherever the plants are found in some form in India. So when we look at this table, which is the next one, this is the profile extracted from our current database. It's a cross tabulation of number of medicinal plant species used across medical systems. So when I say Ayurveda, if you see both column and row, if both sides read Ayurveda, that is the number of species known and recorded in Ayurveda, 1539. So our database shows 1539 in Ayurveda. Our database shows, let's say in Siddha, if you see Siddha vertical and Siddha horizontal, 1152. Sovarikpa, we have list of 252. Unani, we have 496. These are the unique species in that particular system. But this tabulation is more than that. It shows overlap between any two systems. For example, under folk, we have 5340 species. But out of this 5340 species, 876 are known in Ayurveda also. Out of this 5340, 161 in homeopathy, 873 are known in Siddha, 187 in Sovarikpa, 332 in Unani, and so on. So this tabulation is showing a whole lot of plant species in terms of their usage are overlapping across different systems. And there are quite a number of species which are known to be used in all of these systems. Ayurveda, Siddha, Unani, homeopathy, everything, even folk traditions. So this we need to appreciate, that plants are not something which are used only in one system or two systems, they are used across systems. Their medicinal properties have been studied and acknowledged into different systems. So this is the total number we are talking about, 6560 as of now. Perhaps it will grow as we bring in more ethnobotanical study data into this. It presently reflects fairly completely the codified system data. But as far as folk tradition data is concerned, it is still not complete, because a whole lot of ethnobotanical studies keep on happening in different parts, in smaller levels, some district level, some taluka level, some Andaman, some study will be there, there will be some in Nicobar. Putting them all together will need much more effort, and therefore, and then it will grow also, the number. But in terms of the challenge to take informed conservation action, how many of these actually need that kind of assessment? We are only talking of conservation action for wild medicine plants. So out of the 6560, we estimate that there are about 5,000 species which occur wild in India. Out of this 6560, 5,000 wild in India. So these are the wild species of medicine plants of India which we need to analyze, attend to, and figure out how many of these are needing urgent conservation action. Now in terms of estimation of medicine plant species in different biogeographic zones, this was drawn, the map was done some 15-16 years back to give an idea that medicinal plant species are not confined to one particular biogeographic zone. They are spread across, and sometimes they do reflect, in spite of smaller areas, large number of species like in Western Ghats, like in Northeast. Sometimes people do not appreciate that even the desert biogeographic zone also has estimated, let's say, 500 medicine plant species growing there. In Trans-Himalayan cold desert region, estimated about 200 medicine plant species occur. So there is no specific biogeographic zone there where you can say there is no medicine plant here. There are medicine plants across these. Somewhere the diversity is high, somewhere it is lesser. But this is the broad picture we need to understand, that these are across, and therefore actions will have to be taken across and in different biogeographic zones. You cannot do medicinal plant conservation only in one area and say done. It has to be done across biogeographic zones. Now, out of these 5,000 species, how many actually are threatened? Actually, from the very beginning in 1995, we have been also engaged in undertaking what we can call threat assessment of wild medicine plants. And that's a rapid exercise which we do through a process which is called CAMP, Conservation Assessment and Management Prioritization, CAMP. That is almost internationally accepted methodology for rapid assessment, and it requires pooling the knowledge of field observations of the experts who have been going around in that area through a 3-day workshop. And that process we have been doing since 1995 using IUCN Red List criteria and categories. And as a result, we have done it for almost 18 states now. But each such exercise is able to handle a maximum of 40 to 50 species. Not all, because there is not enough time. In one species, you spend a lot of time to figure out where is it, what is it. So we need a lot of prioritization for doing that, and then assessment through that rapid process. And then you need also ground truthing, because sometime you may not be knowing enough data. So you go back to the field and do that. So what we have been doing is now, of course, contributed to IUCN Red List of Medicinal Plants of India, where we have uploaded many of species. But in terms of an estimate of how many of these 5,000 species could be such which we can say are threatened with extinction. In order to make an estimate, we have drawn from an assessment undertaken by Royal Botanical Garden Kew along with IUCN in 2010, where they estimated that at the global level, 1 in 5 of the wild species, plant species, 1 in 5 are threatened with extinction. That means 20% of all wild plants are now threatened with extinction. That is the assessment done globally. Since we don't have any assessment for India, we apply the same 20% criteria on these 5,000. So if you apply that 20% criteria in 5,000, we are talking of 1,000 wild Indian medicinal plants which perhaps are threatened with extinction, but we don't know which ones are these. Whatever we have done in different states has added up to about 300 and odd species, but many of those assessments are actually very local and regional assessments, not necessarily global, because the knowledge available in a particular workshop is only local and not global, except the endemic ones, for which, of course, whatever you do assess for a local region is also the global assessment. So there is a large gap. We still need to do a lot of work to fill the gap, to find out species of conservation concern, and then take action. So if you want to take action, you need to figure that out also. Now this is the kind of mapping we have been doing. We have done it for more than 2,000 species. Many of these are on the NMPB website also. But this is purely from available literature, the published floras and research papers. And you can see that this particular Embellia ribes, which is source of plant drug known as Vidanga. If you see the maps, there is a second map which shows red patches on green background. Green background is showing the states. But once you narrow it down to the districts where it has been found present is very limited. For example, in southern India, it is only along the Western Ghats. And in the east, it is along the eastern Ghats of Orissa and part of Chhattisgarh, and then going into Arunachal. So this shows that at the state level, you might spread and cover the entire country saying this is found in all states. But actually, when you narrow it down, even at the district level, which is quite big unit, you get a very patchy picture that it shows that actually the species is not very widespread. It is very restricted. And in fact, whatever Vidanga, as per Ayurvedic pharmacopoeia, this is the source of Vidanga, which is Embellia ribes. But in actual practice, if you collect the market samples, 90% is Embellia xerium cotum, which is a different species, which is being used as an equivalent. And perhaps okay at that level, but we need to understand both. Which of these? So Embellia ribes for us is more of higher conservation concern. Whereas even the second one could be of conservation concern, but here you can see that spread is wider. It's also there in, let's say, Rajaji National Park of Uttarakhand. Embellia ribes is not there, Embellia xerium cotum is there. Embelius germcotum is in abundance in Chhattisgarh, and large of supplies come from there. It's also present in Arunachal, it's also present in the Western Ghats. So this is what is much more available and much more harvested and used. And much easier to harvest also, it's a shrub where one can access, whereas Embellia ribes is a huge woody climber liana which fruits at the top of the tree is very difficult to harvest even. But this mapping is essential to figure out where it is, from state to district level. Now we go to what we can call ecogeographic mapping, where we use the precise locations, convert those locations into latitude, longitude coordinates, and put it on a map. In fact, we started this work for this particular species somewhere in 97, 98, when we drew the first map, and where we ourselves at that time digitized. Now digitized layers are available on the net, but that time we digitized ourselves altitude, rainfall, vegetation type layers, and put these locations from where it had been collected. So in this map, if you look at closely, there are markings like H, which shows herbarium specimen, and P, which is population records based on our own visits. So there are population records and herbarium specimen collected, and there are these 13 such locations now known to us. We have been constantly looking for it, and that's how we know where precisely these are found. But initially we had only about 6 or 7 locations from herbarium specimen and some field observations, and then we put it on the map. The colors here represents the altitude range, 0 to 150, 153, and these are the standard layers available in the maps at that time. So we digitized them, and then hatching is the rainfall. You can see that the rainfall, highest rainfall in this actually is along the Western Ghats, and when we correlated the altitude and rainfall with the presence of this species, we could figure out that this species occurs in altitudes which are around 900 meter or so, but prefers rainfall which is above 4000 millimeters. It is very high rainfall. Very few locations where it is slightly less than 4000 it is also found. So this correlation between altitude, rainfall made us figure out that, and we were looking for a wild population to be conserved. Our purpose was to take a conservation action. So when we started looking for, so we said it has to be in a belt somewhere in Kerala, or it could be in Karnataka, but we need to go down to the ground to locate, and it could be searched in an area where there is a high rainfall zone, more than 4000 millimeter, and altitude range is matching about 900 meters or so. With this combination, we searched at that time and located an area which is in Idukki district of Kerala, and we set up a medicinal plant conservation area for this particular species. So the action taken in terms of establishing a conservation site was based on this rigorous analysis of species which is of high conservation concern. We assessed it to be critically endangered, picked up its location from the herbarium specimen and our own observations, put it on the map, digitized these maps, interpreted the correlation, searched the ground and located. Ideally, this is the picture which you need to follow, but we could do that only in the last phase of the project which we were doing at that time. That project was from 93 and continued till 2004. But by the time we were armed with this kind of information and analysis, it was already somewhere 2001-2, and the funding agency at that time said you can at the best add another 4 medicinal plant conservation areas only, because we are now nearing end. So we had already established 30 based on general parameters of ecology and high possibility of presence of diversity of medicinal plants. But last 4 we were given the choice. to locate it for capturing specific populations of medicinal plants of high conservation concern. And we established those 4, one for Cocinium fenestratum, one for Janakia arelpatra, which is in Tamil Nadu now, Nambikoil is the place. One was for Saraka Ashoka, which was done in Karnataka, an area called Kollur. And there was one which was done for Utilaria salicifolia. 3 of these species are found nowhere else except in Western Ghats. Utilaria salicifolia, Janakia arelpatra and Cocinium fenestratum, Western Ghats. Cocinium is also found a little bit in Sri Lanka, but mainly in Western Ghats of India. Saraka Ashoka is found only in India. Problem of confusion arose because initially the type specimen was collected from Burma, which was named Saraka indica. So other botanists who worked in continent also named it Saraka indica, which was wrong. It was not same species. So now if you look at it, the species which we know as proper Ashoka is Saraka Ashoka, not Saraka indica. So Saraka Ashoka synonym is Saraka indica oc non linen, which botanists will understand what it means. It means that it is Saraka indica but non linen. Others have named it Saraka indica. It is not really indica. So people are still confused. Many of the literature still says Saraka indica. Wrong. It is Saraka Ashoka only, and it is confined to Indian subcontinent with little presence also in Sri Lanka. This information you arrive at after the studying, analyzing, understanding. It doesn't happen in just like that. I mean, you need lot of work on this. So Saraka Ashoka is endemic to India almost, except Sri Lankan presence, and its wild populations we have been studying. Its real wild population where you could capture it for conservation is only in Karnataka, Goa, in Orissa, Meghalaya and Mizoram. Now we know Mizoram, last visit to Mizoram, we were monitoring an MPP project and Dr. Rawat, me and others were there, and then we figured out that yes, they do have, and they had not documented it very well, but we asked them to, and they documented then that there is a viable population of Saraka Ashoka in Mizoram also, which is not known. Now recently in Tripura we were doing it, and they said there are wild Saraka Ashoka present in Tripura also, along some streams, a few trees.
Actually, sir, during 1986, I have recorded it from Tirap district of Arunachal.
Tirap also. So some sporadic presence along streams is also in Kerala,
Yes.
also in Meghalaya. But if you look at population for,
Very rare.
then you have to go to Karnataka, maybe Orissa, and maybe Mizoram. That kind of picture. So conservation action you can take with focus once you analyze and understand this. When we started this whole conservation program back in 93, we didn't know where the Cocinium fenestratum is, where to locate and what to do. The fact that Saraka Ashoka is confined to these areas is a result of shifting the data over and over again and then mapping. Without that, broad statement, if you hear from, I am not blaming botanists, but there are botanists here, they say all over India, Saraka Ashoka all over India. No differentiation between wild and planted. It's an ornamental, planted many places. But where is the wild gene pool? You need to conserve the wild gene pool, which has the diversity, which will make it survive on a long-term basis. If you don't do that, planted ones can die in one go with one disease. Wild gene pool will have diversity. That is what you need to conserve. So, conservation action has to be for wild gene pool, and that effort you need to figure out which are the wild ones, which are declining fast, map them at a broad state level, district level, map them at the precise location level, interpret the correlation with bioclimatic factors, interpret potential zones. Nowadays technology is available on the net. You have GIS and Maxent model and QGIS, and you have all these facilities available, bioclim layers available. So interpretation is much more. We started with all blank ourselves. We have to digitize each, even state boundaries we have to digitize. 95, 6, 7. We have to do all the digitization ourselves. It was quite a task. Now these layers are available. Now nothing else, you have Google Earth also, which is not very reliable, but still good enough to do this work. Good enough to do this work. So now technology has improved and a lot of potential exists to take it forward through modeling and so on. Modeling has not been done yet enough. What we call ENM, ecological niche modeling, is being done, but more for research purpose and papers publication, not for conservation action yet. What we need to do is use that methodology to actually promote conservation, and for that you need prioritization. You need understanding which species where, which one to do ENM. You should not do ENM for species which are very abundant and common. What is the purpose? So this is the kind of mapping we think we need to do for species of high conservation concern, and it has to be an ongoing program. You have to keep on building as you come across more locations. You add and you improve. And once you keep on improving the data of presence with correlation of bioclimatic factors, your projection, your modeling keeps on improving. You get more clarity as to where possibly this is, where else this is. And this is how we need to use this GIS technology for conservation action. This is how we have done. We have done, this is the very old 97, 98 map which we did at that time using, as I said, ourselves digitizing everything, where altitude and rainfall are the combination. Color is altitude and hatching is rainfall. And this combination again we did for mapping, which is Myristica. This is Myristica malabarica. Myristica fragrans is not wild in India. That is nutmeg. That is Jati Patri, but that's not wild in India. It is all planted in Kerala and most of places. But this Myristica malabarica is wild in India, in the Western Ghats. It's a typical element, mostly favoring mangroves and areas, and little so lower altitude, high rainfall zone, but in Western Ghats. Endemic to India, Western Ghats, nowhere else. It is traded in the market as Bombay nutmeg to differentiate it from fragrance, which is the real nutmeg, which is more of a spice. This one is more medicinal. It's also known in Ayurvedic pharmacopoeia as Pasupasi, in that name. But otherwise it's traded in the name of Bombay nutmeg or wild Jati Patri. That's how it is. So eril is Jati Patri and nut is Jaifal, Javitri. So when we analyze and map, this is found along this thing, and typical habitat we have photographed where it is coming up, these new seedlings. But this, what we found in our analysis is that this species is also highly threatened. In fact, in one of the workshops, one of the very well-known botanists of Karnataka, he stood up and said, why you are assessing this? In my backyard, in that area in Uttar Kannada, we have maybe 100 trees of this. Why you are assessing it threatened? We said, good, but let us know, is there a regeneration? How many younger trees? How many older trees? You need to look at the population. So he got the point. He said, yes, you are right. There is only mature trees who are fruiting, but there is no young generation. Why? Because the fruits are being harvested entirely. None of these fruits is being allowed to regenerate. So as a result, there is no young population. It's only mature, and when this mature population dies, it is wiped out. This place will not have any Myristica. So it is threatened. You don't look at just what you see as a good population of trees. You need to look at the regeneration, the younger crop which is taking up. If you don't have that age gradation, future is bleak. This is going to be lost. So taxonomists need to look at it from ecology angle also, which is the missing point as of now. Taxonomists tend to overlook this part, and taxonomists are the one who are going to the field to study this. Another group who is going to the field is the forest people, but they don't recognize easily. Their identification is not so good, so they will not be able to observe. Taxonomists are only happy with recording presence in this location and not looking at ecology side. So we need to change the perspective, look at the ecology, look at what is happening. So this is also a threatened species, and we have mapped it, and therefore with this help we can establish some conservation sites, and this has to be somewhere in Karnataka or maybe a little bit in Kerala, but not elsewhere, not found anywhere else. This is again a mapping of Veteria indica. Its resin is tapped, which is used in same way as resin of Shorea robusta, sal. But it is endemic to Western Ghats, Veteria indica. In areas along Mangalore and all, roadside planted heavily. So everywhere you will see this. So some people came back and said, why you are assessing this? This is all over the place, planted. We have to make them understand that we are looking at what is happening to your wild resource. Is the wild resource declining? And what is happening to it? And based on that, the assessment is done. So our assessment for threatened status is only for the wild, not for the planted one. You can plant up thousands of plants of a species. It is good to plant. You can use it for example, if you want to use Saraka Ashoka bark extensively in medicine, you plant, harvest, use, but keep the wild gene pool reserved on a long-term basis as a conservation site, and that's what we need to do. So this mapping, this is how we. Also, we have used this mapping for what we call estimating extent of occurrence of endemic species for applying IUCN Red List criteria. The IUCN Red List criteria as defined in the latest version 3.1 is that if a particular species which is endemic, if its extent of occurrence is less than 20,000 square kilometer, then it is vulnerable. If the extent of occurrence is less than 5,000 square kilometer, it is endangered. And if the extent of occurrence is less than 100 square kilometer, it is critically endangered. But this criteria applies only for endemic species, which is found in, let's say, in particular region and nowhere else in the world. Then it applies. So, in order to figure out that, we mapped this particular species, which is Cinnamomum whitei. It's a wild cinnamon of Western Ghats. There are 5-6 different species, but this particular Cinnamomum whitei occurs naturally in the hilltops, in the Shola forests of Western Ghats. So we carefully studied, documented from the herbaria, our own field visits, mapped these locations. So when we did this mapping, these are the two distinct zones. One is in Nilgiri Hills and other is in this Annamalai Hills. And in between there is a Palghat Gap. So the Palghat Gap connects the Kerala and Tamil Nadu area, which is lower altitude, but both sides there are hills. And on hilltops this species occurs. So once we mapped these 20 odd locations, we calculated using this facility of map itself to work out the extent of occurrence. In this case, it worked out to some 10,000 something, 118.04 square kilometer. That means it is more than 5,000 but less than 20,000 square kilometer. So this becomes vulnerable as per this criteria. But the second criteria is area of occupancy. Area of occupancy for these 21 sites based on 1 square kilometer proportion for each presence works out to some 116 square kilometer, and not 100, this is, yeah. So that makes it,
160.
so that makes it endangered kind of thing. So two different criteria. So what I'm sharing with you is that this mapping methodology is also useful for working out these parameters for endemic species. This is what we do for assessing these. Now we take a case of Saraka Ashoka. As I said, we have just picked up the 3 altitude range layers, which is 300, 600, 6 to 9 and 9 to 1300, and that is colored here, and purple color is 900 to 1300. And along Western Ghats, wherever we could find, we have mapped this and located. Those yellow dots are showing exact locations where from it has been recorded. And in the northeast, we have this location in Meghalaya, and some urban specific locations also. From literature record, there are some locations in Mizoram and all. So this facility of picking up the specific layers and then seeing the correlation is now available. In fact, this is a projection of potential zone in East and Northeast India for Saraka Ashoka using ecological niche modeling with DEVA GIS and Maxent. So if you see, we just use the Western Ghat locations, which is given on the side 1 map, and using that we have the potential, Maxent model potential. Red shows the highest potential. So you can see red patch is either in Orissa somewhere or more in somewhere in Meghalaya and maybe a little bit in near Mizoram somewhere. So this is the modeling which is now available, which we can use for projecting potential areas of occurrence. We only knew of the Western Ghats, and using that we can project and see that where else possibly this is present. And that's how we come to this. And as we get more locations and mark them precisely, even for Odisha, and the model will improve. It will show more accurately the potential areas, which you could then ground truth and verify and then take conservation action. So this is how we think we can use this technology for conservation action. What we have been also doing is trying to do mapping backward linkage. We have this high trade botanical drug called Daru Haridra, Daru Haldi, and the sort of accepted source of this Daru Haldi as per pharmacopoeia, Ayurvedic pharmacopoeia, is Berberis aristata. But in actual use, it is not only aristata, it is also Berberis lycium, it is also Berberis asiatica. But it doesn't stop there. It is also species of Mahonia, Mahonia nepalensis, which is Himalayan, Mahonia leschnaltii, which is Western Ghats, and you have even Berberis, one species found in Nilgiri hills of Tamil Nadu, Berberis tinctoria. Unfortunately, in older records, they have named it Berberis aristata. Slowly, things have cleared that that is not aristata, that is tinctoria. But that's also being used. So you have to, if you want to figure out where from all the Daru Haridra which is being used by Ayurvedic industry is coming from, you would need to understand distribution mapping for all these species, not one. Potentially it could be Berberis aristata, Berberis lycium, Berberis asiatica, Mahonia leschnaltii, Mahonia nepalensis. It could be Berberis tinctoria. So there are sort of this kind of studies which need, and this also needs mapping and interpretation. So we need to use that kind of study also to figure out, because otherwise you don't know. As of today, we don't have a system where a particular industry using a medicinal plant is able to tell you where from they are getting it, unless they are getting it cultivated source. Cultivated is fine, but Wilds, where are you getting? They won't be able to give you any reply. But you still need to get a link between what is being consumed and where from possibly it is coming. And for that we need again mapping of this kind, where from it is coming, and where we could look at for conservation action, even for resource augmentation. Tomorrow we decide that if industry has to use only Berberis radiata, where should it be cultivated, planted in a big way, backward. This maps will only tell you where, because it has to ecologically suit. So ecologically you have to interpret and find where possibly you can. If you want Myristica malabarica to be planted, obviously it has to go to that zone and plant there. Taking Myristica malabarica and planting somewhere else will not succeed. It may plant, it may grow, it may not produce fruits, and that's what you need. So whole lot of things, and ecologically it may not suit. It may not have the medicinal properties even, because quite a bit of medicinal property is because of the ecology in which it is. So we need to understand all this, and therefore mapping is important even for that. Now geographical distribution, which we have been doing as part of Center of Excellence program under Ministry of Environment and Forest, and that we found that we were doing it on a CD, as an atlas, but people are not very eager to use CDs these days. Nobody uses. Everybody wants to go to the net and do whatever. So we decided that to disseminate this information, the best way is to connect it to some national portal, in this case Bhuvan of NRSA, which therefore we have provided them all those geodistribution maps of the species which we have done, and they have shared it on their platform. So for out of those which we have mapped, they can see through Bhuvan portal also, and we have these precise locations which you can see in red colors. These are the medicinal plant conservation areas which we had coordinated for setting up under different projects across the country. There are 108 of these locations. So this is also a kind of a application of maps for disseminating knowledge and information about where and how many species are found in different states. Mapping geographical distribution of the prioritized wild medicinal plant species, depicting regions of their recorded natural occurrence, has to be initiated as the first step. There is no option. We have to map and natural distribution. No confusion about planted and so on. Natural distribution. And in respect of species which we call of significant conservation concern, we need to take up ecogeographic mapping, because we need to correlate the ecological conditions with the presence using GIS technology to establish correlation between their natural occurrence and the ecological parameters. And that's now much more easier and facilitated because of a whole lot of layers available on the net itself. So ecogeographic maps along with ecological niche modeling can identify the potential areas of natural occurrence, and then this analysis can then be followed up through ground truthing of wild populations, and an informed conservation action can then take place. Where to conserve these as the wild gene pool, where possibly to even do the resource augmentation. The answers will come if you do this mapping. I think NMPB is also starting something like this. That's why you are here.
So basically, for the MPCA, Medicinal Plant Conservation Area, when I looked at your data from FRL history, some of the medicinal plant conservation areas are matching, and some from the projects does not match because they are given by the Forest Development Corporation and Forest Organization, and we have around 80 so far from the projects. I have got the 80 latitude longitude locations of the MPCA areas, so I have mapped them as a point data.
Okay.
But I want to go for that polygon data. What is the polygon and what are the species? But most of them have documented in the literature also. So it needs to be for medicinal plant conservation area. I want to that species distribution modeling also, which species are there in medicine, what are the conservation and as per the IUCN or the threat stats endemic species. So NMPB is doing like that, but it needs resources, and so GIS, using GIS technology and using the MaxNet softwares, we
Yeah.
can do the individual species distribution modeling, which are very high in demand and which needs to be prioritized. So NMPB should took the initiative as soon as we were waiting for this DPR and detailed project report from which images we need, and we can develop also spectral profiles using image processing softwares, and from that we can give the more information to the public with related to these type of technology.
Yeah, as of now, the application of satellite imagery, interpreted imageries for sort of identifying zones of occurrence of specific species may work for the species which are in top canopy, which are the trees. When it comes to herbs and shrubs, you will have to first develop a correlation
Correlation.
with that.
between the presence of canopy trees and the shrubs. So you will have to do a whole lot of ground truthing.
Yes.
Whole lot of ground truthing and training sets to be developed, and then you interpret the imagery and correlations and then slowly build this. It's not going to happen immediately
Yes, sir.
because as of now you don't know how it is.
No.
It is complex.
It needs to take an initiative, and slowly it will work.
Yeah, slowly it will work. But it will need a whole lot of
A lot of
Training sets
Training
later.
sets.
you have to go to the ground, collect, correlate, all that.
Actually, sir, just telling for tree species, some say coffee we can do, some taxus.
Yeah.
In that cases
True.
we can do. But for
Yes.
annuals and perennials, it is quite difficult to.
As of now, there is
Yes,
nothing which you can
without
interpret. You
taxonomical
have to
studies.
develop the correlations.
Yeah, you are telling right. We can do like this, but it is very tough. If you go in the field data, there may be say aconitum one species. We are not getting today the herbarium specimens. So if you go in the field, it is very difficult to get critically endangered species
True.
for herbarium specimens. So this is the actual scenario of the endangered species in the
Yeah,
nature.
some of the species are so rare.
So rare.
Now, and especially they have declined so much.
So much. So you will try to collect Coptis data in Arunachal Pradesh. You have very limited populations in the wild. But
True. There are big challenges there.
Yes, sir.
Some of the species are very rare.
Yeah.
Very rare. And in fact, people do not sufficiently distinguish between wild and planted ones.
Planted.
When
They
we are
keep
unable
mixing
to
things.
get-
We were in Tripura camp workshop.
Yes, sir. Yes.
And initial run, we asked the local experts, species which you like to assess. They named all these Aquilaria, Malacensis,
Yes.
Mesoaferia, but when it came to assessment, they all agreed that there is no wild presence anywhere left now of Aquilaria or Mesoaferia.
Only one or two. If you survey whole area, in Aquilaria populations are so limited. If you go in the Assam, you will get plantations. Now it is well
Plantations are
planted.
there.
Well
Plantations are there, but where is the wild
the
source?
natural source is very, very rare.
Where is the wild source? Because that is critical. You need to conserve the wild gene pool.
Yeah.
You have almost finished a
Finished.
wild source of Aquilaria malacensis.
Yes.
Almost finished.
Yes.
Agarwood.
Okay.
Because from outside people were unable to at least figure out whether it has the infection, which is of value. So they would cut the trees and see open and find nothing, and the trees felt then it is done and gone. Now there is some technology of infecting using some borer or something, and but it's still not perfected.
No.
So a lot of it is still to be worked out.
Yes.
Aquilaria we don't know now.
Yes, sir. Actually, sir, NMPB has also supported
Hmm.
one project to this Forest Research Institute, Jorhat, regarding this infestation of this Aquilaria wood. Probably they are doing some good exercise.
They have a plot.
Yeah.
We saw that plot.
Ji.
They have in
They are,
Agartala.
yes,
They are doing the study. That is that
probably.
true. They are doing it, but it will take time to understand. So this is broadly what I wanted to share with you. But